Hey students, we're on 10.3 today. We're going to be talking about shapes of distribution. So when we graph our data, what does the shape tell us about what's going on? So that is what we're looking at right here. Hopefully you watched the video from last week on Thursday on shapes of distribution. If you have not yet watched that video, I'm going to put it in the Schoology folder for today also. So if you haven't watched that video yet, you need to go back and start there and then come back to this video. Okay, to begin with, let's look at our bell work. This paper right here, this one, I'm going to call you up, kind of like what we did last week, and I'm going to have you do this little, let's see if you know how to do a histogram. So I'm going to call each student up to do this little questionnaire right here. So we're going to just kind of not go over that right now, of course, because we'll do that together. We're going to go over your bell work. So first of all, it wants us to order these numbers from greatest to least. So we want the biggest number first. Now they're all in the negatives. So which one is... Oh, I'm sorry, it's from least to greatest. So which one is the furthest away from 0 on the left-hand side? If you look at the up in front of the room, you can see that nice number line up there. You can use that. We can see that this number is the furthest away. So that is going to be negative 2 2/3. So I'm going to cross that off my list. Then we would have negative 2. Then negative 1 3/4, sorry. Then negative 1 1/4. And then negative 1/3. So let's plot these on a number line now. So negative 2 2/3 would be about right here. So I'm going to call that A. B would be right on the line, so that's B. C would be 1 3/4, which is really close to B. It's right there, C. D would be negative 1 1/4, which is about right there. And E would be negative 1/3. That would be about right there. Okay, so number 1, there you go. That's how you do that one. Number 2, we're going to go over these percentages. Again, how to find a percent. 10 is 20% of what? Now, this little formula will always help you with percentages, so you really need to know this. We're going to remember that this is of, and then the percent goes on the top of the 100 on the other side. So we know that 20 goes there, and 10 is, so 10 goes here, and what we don't know is that, so it's x. So we're going to go 20 times x is 20x, and then we have 10 times 100, so 10 hundredths is 1,000. Now, this is like an equation, and we haven't really talked a whole lot about equations, but just you need to understand that we always use inverse operations to undo things in an equation. And this says 20 times x, so 20x means 20 times x. So we're going to undo that multiplication by using division. And we divide by 20, because what is 20 over 20? It's 1. And 1 times x is 1x. Or another way that we can call it, 1x is just x. So this just turns into x because of that. And the other thing that you have to remember about undoing equations is that what you do on one side of the equation, you have to do it on the other side of this equal sign. That's kind of why I have those bars there. And there's our equal sign. We have to do the same thing over here. So we're going to take 1,000 and divide it by 20. And we get 50. So x equals 50. So this right here would be a 50. So 10 over 50 is 20%. So that's what we're looking for right there. Okay, so number 3, write an equation to represent the sum of b and 24 is 58. So the sum of b and 24 would be b plus 24 is means equals, and 58 would be that. And we could solve this, but it doesn't say to solve it. So we'll leave it at right there as that. All right, let's move on. All right, some things that we need to talk about when we get into shapes of distribution. First of all, we are coming to the end of the chapter, of the unit, and some of the words that we're going to be using, you are already familiar with them. But there are a few things that you need to be aware of. First thing that I want you to be aware of is I want to look at these three graphs right here. And you can see that one of them's called skewed left, one of them's called skewed right, and one of them's symmetric. And the thing that I want to talk to you about here is if we trace the tops of those graph, of our data points in our graph, well, if we were going to call this some sort of animal, this would be probably where the head is, right? And this over here would be the tail. And wherever the tail is what tells you if it's skewed left or skewed right. So if the tail is on the left-hand side, which it is right here, that's why it's skewed left. Again, if we trace this, you can see that if this was a little guy, a little monster, a whale, or a fish, I don't know, that its tail is on the right-hand side. And if its tail is on the right-hand side, then it's going to be skewed right. And then you have this guy down here that looks the same on both sides. It's called symmetric. And the reason it's called symmetric is because symmetrical means the same on both sides. So if you were to look in a mirror, that's a good example of it being symmetrical, because what you see on one side of the mirror is what's on, it's a reflection of it. So that is just kind of setting you up for what we're going to talk about here right now. So we're going to talk about shape of distribution, and we want to describe the distribution of these data sets. So we can use skewed left, skewed right, and symmetric to kind of categorize these. But we can also use other things, like some of the words that we are already aware of. So let's take a look at this first one. Right here it says groups of students from 3 different grades were given a quiz on 6th grade math topics. And here's the results. There's a few that got zeros because they're 4th graders taking a 6th grade test. That makes sense why we have low scores, because, we don't have any students they haven't even learned it yet. So again, I want to look at what's our minimum. Well, we have a minimum of 0. We also have a max of 10. Do we have any peaks? Yep, 2. Do we have any gaps? Yes, 8. Is there an outlier? I would definitely say that your outlier, you could say 10. You could also possibly say 9 to 10 would be outliers. And do we have any clusters? Yes, our cluster goes from 0 to 7. Okay, so if we were to draw this thing, and you can see that our head would be here, right? Because that's where the cluster is, and our monster, or whatever you want to call it, his tail's over here. And if we compare it to this guy over here, it would be skewed right. So we have this data is skewed right. Okay, moving on, let's take a look at the 5th graders taking the 6th grade score. And we can see that we have a minimum of 1, and we have a maximum of 9. We have a peak at 5, and our gap, we have no gaps. We also have no outliers in this set of data. And our cluster goes from 1 to 9. Again, if we traced all of the tops of our little dot plots right here, we can see that this data would be symmetric. So I'm going to write that right here. This is symmetric. Okay, so now let's take a look at this next one. These are the 6th graders taking the 6th grade quiz. So we see some really good scores here. Our minimum is 5. Our maximum is 10. We have a peak at 9. We have a gap from 0 to 4. Do we have any outliers? None. No outliers. Do we have a cluster? Yes, from 5 to 10. Again, if we trace this thing, our monster guy, or whatever you want to call it, where would his tail be? His tail would be over here. So this would be, let's zoom in, skewed left. So there it is. So I'll write that down on here. So this is skewed left. Now, occasionally you'll run into some data. When you plot it, it looks like this. And it is rather hard to categorize. It's hard. Let's look at our different things here. We have a minimum of 0, a maximum of 10. We have a peak at 3. We have 2 gaps here. We have a gap from 1 to 2. And we also have a gap at 6. Do we have any outliers? Yeah, 0 is an outlier. And then do we have any clusters? We actually have 2 sets of clusters here. So we have a cluster from 3 to 5, and we have a cluster from 7 to 10. So if we were to trace this, it would look hard to categorize because it's not skewed left, it's not skewed right. Well, what is it then? Well, if it's not skewed left and it's not skewed right, and the data is just kind of evenly distributed throughout your graph, then we've got another symmetrical one here. So it is symmetrical even though it doesn't appear to be. It's, the data is pretty evenly distributed through the entire graph. So those are some of the things that you need to be aware of as we go through your practice and we go through your assignment. All right, so here we are. We're looking at your practice now. So let's look at this number 1 and number 2. Again, if I trace this, the tops of my data, what would you say that? It says describe the shape. Well, what would you call it? I would call this symmetrical. All right, so if I trace the top of this next one, where would the mouth be? We'd be like right here. So where's his tail? His tail's on the right-hand side, so this would be skewed right. Okay, so what does that look like when we're looking at something other than a dot plot? Can we still determine if it's symmetrical or skewed left or skewed right? We absolutely can. So again, we have our data here and it goes downhill. Well, where's the tail at? Okay, the head's over here, right? So our tail's over here, so this one would be skewed right. Okay, we're going from here up and then back down. This would be another example of symmetrical. All right, so moving on. Number 5, it wants us to actually build a frequency table. And then, well, the frequency table shows the number of months each person has been a member of a golf league. Display the data in a histogram. We know how to make a histogram. And then describe the shape of the distribution and include a title and label the X and the Y axis. So it wants us to make a histogram, and we got to give it a title. And we've got to talk about what the X and the Y is. So the way that I'm looking at this, I want to call my frequency down here. So I'm going to go frequency. And then I'm going to label these. Actually, you know what? No, I'm not. I want to do it opposite of that. Sorry. I want to call this months as a member. So months. And then over here, I want the frequency. So I'm going to go frequency. Okay. And the title is what? What do you think? Yeah, we're going to call this months of the months member of a golf club. Like that. All right. And then I want to probably go, you know what? Where's my range? I need this thing to go all the way up to 12. So we need to know what to count by. So we have to make a decision. Okay, there's 0, 2, 4, 6, 8, 10, 12. Do I have enough? Yep, I do. So let's label all of our stuff now. So 2, 4, 6, 8, 10, 12. And then down here, we got to make our categories. So this is a 0 to 4. This is a 5 to 9. This is a 10 to 14. Then we've got a 15 to 19. Then a 20 to 24. Then a 25 to 29. And then a 30 to 34. All right, so let's use some different color here to kind of make this stand out, the categories. So my 0 to 4 is a 4. So I'm going to go right here. Let's fill that in so we can easily see that that's what that is. And then my 5 to 9 is 6. So let's go up to 6 from here. And I hope you do a better job at shading than I am doing. Then let's go to 8 would be, or the 10 to 4 would be 8. So we're going to go right here up to 8. Shade that in. And then we got 15 to 19 that we are going to 10. So we'll go all the way up to 10 there and shade it in. And then we've got the 20 to 24. We've got 12. So we've got to go all the way up to the top, up to 12. And then we've got the 25 to 29, which is also 12. And then we've got the 30 to 34, which is 8. So we'll go right to there. All right. So we did that. We want to describe the shape of the distribution. So what is the shape of this distribution? Well, again, if we look at where the head is and where the tail is, I would say that this is the tail right here, and it's on the left-hand side. So we have some skewed left. Okay, so not too difficult. Let's look at your assignment. All right, looking at your assignment, it's kind of the same thing, except that you're having to make some different histograms here. So the frequency table shows the ages of the members of 2 local fitness clubs. So we have A and B. So I would do A over here and B here and do this data. And kind of, if you need help, look at that practice and look at what I did to build this. So you want to label everything, and then you're going to need to see which one, answer this question right here and tell why. So not too difficult. Again, if you need help, please ask your teacher. We are here to help you. And good luck.